name is Michael King. In this third video on capital budgeting, we're going to look at internal rate of return and compare it with net present value. This is going to be sections 13.1, 13.2 in both Clear and Rakita. So you may have heard of internal rate of return, or IRR. What discount rate would set the present value of the cash flows equal to zero is going to be IRR. How do we solve for this? Well, we're going to have to iterate using trial and error, which is a time-consuming process if you have to do it by hand. But fortunately, computers and Excel have built-in functions that can solve this for you. Another way of thinking of IRR is it is the discount rate that will set the net present value of a project's cash flows equal to zero. In other words, it will set all the inflows equal to the outflow today. So it's the discount rate that will set the outflows in present value terms to the inflows in present value terms. And just slightly rearranging, subtracting inflows from both sides, we see that it's going to set the difference to zero, which means by definition and net present value is going to be zero. So coming back to our example that we looked at with that upfront investment of $150,000, savings of $40,000, salvage value of $40,000, savings each year of $50,000, and a discount rate. Let's take a look. Well, as we saw when we discounted at 9%, there was a positive NPV. We could see that the positive NPV was $70,480. The question is, what discount rate would actually lead to that net present value being exactly equal to zero? Or in other words, what is the rate that we would expect to earn on this project? Okay, notice that at 9% there's a positive NPV, so we're going to want to increase the discount rate such that that NPV goes down. In fact, if we iterate, we're going to find that you would go all the way up to 24.3%. Using that as the discount rate, you can see here that discounting the cash flows and summing them up, that they will sum exactly to zero. That is what is meant by IRR. IRR is the discount rate that sets the net present value to zero by setting all of the present value of all the future cash flows equal to the outflow today. We've actually looked at IRR before. We've seen that IRR can be used to value a bond, although we didn't call it internal rate of return. Instead, what we did was we called it yield to maturity. What we did was we looked at all the future cash flows that you would receive as a bondholder, namely the coupon and the face value, and we set them equal to the price today. Or, in other words, we solved for the price today by discounting all the future cash flows at some rate called the yield to maturity. So, the yield to maturity on a bond is actually the IRR because it sets the present value of all the coupons and the face value equal to the price. As we saw here, as 6 years to maturity, annual coupons of 4%, the price today of $970. You can see the cash flows, which are the coupons every year $40, the repayment of the face value in year 6, summing those up along with the price today of minus $970, and discounting them using the yield to maturity here, which is also the periodic rate because we're looking at annual compounding. You can see that the cumulative present value of this project is zero. In other words, a bond is a zero NPV project. Another way of thinking about it is to actually graph the net present value of a project using different discount rates. And what we find is that as the discount rate increases, the net present value falls. And at some point, the net present value is going to cross over the horizontal axis, meaning that the net present value is zero. In this example, you can see that it happens somewhere between 10 and 15%, or 12.5%. That would be the IRR, because that is the rate that is going to set those cash flows, the net present value, equal to zero. So you may be wondering which one's better, NPV or IRR. Well, net present value is going to be better because it works for all types of problems, whereas with internal rate of return, as we're going to see in a moment, there can be some difficulty in both ranking projects as well as dealing with projects that have cash flows that oscillate or vary from positive to negative. It's also going to be easier to rank projects using net present value than with IRR. So net present value is used to compare the upfront costs with the expected cash flows, taking into account the time value of money, whereas internal rate of return is a discount rate that is going to set the net present value equal to 0. So let's take a look what happens when you have two projects where you have to choose one or the other, which is called a mutually exclusive projects. You may have to invest only in project A, and if you do, you can't invest in project B. So we need to look at both projects and choose the one with the highest NPV. So what we're going to do is we're going to graph those projects, net present value on the vertical axis and the discount rate on the horizontal axis, and we're going to look at what the net present value, how it varies. If you're told that project A has an IRR of 12% and project B has an IRR of 15%, which one would you choose? Well, if IRR is your return, you would want to choose the project with the higher return, project B, because 15% is higher than 12%. Or would you? The answer is not as obvious as you think. The reason is that the two projects have different profiles or sensitivity to the discount rate. What this means is that the timing that the cash flows are received is going to affect whether you get a higher or lower net present value. So you can see here that the two projects actually will generate the same net present value at a rate of 9%. That's where they cross over those two lines. Notice that where they cross the horizontal axis, where NPV is equal to 0, that is where we're seeing the IRR. So you can see project A crosses at 12% and project B crosses at 15%. So which project do we choose? Well, we want the project with the highest NPV, which is not necessarily the project with the highest IRR. Look at the graph. When the discount rate is actually lower than that 9% crossover rate, you can see that project A's cash flows, or NPV, are higher. They're actually above, and you can see that it stretches all the way up to 700 at a very low discount rate. Actually, at a discount rate below 9%, you would want to choose project A. When the project's discount rate is greater than 9%, but less than 15%, you're going to want to choose project B, because all the way from 9 to 15%, that project B is going to generate a positive NPV, and the NPV is going to be greater than the NPV for project A. Why do we stop at 15%? Well, once it crosses over 15%, once the discount rate becomes higher than that, the NPV of project B also is negative, and we do not want to accept projects with negative NPVs. So above 15%, you would not choose either projects. Okay, so in summary, you would choose project A if the discount rate is below 9%. You would choose project B if the discount rate is between 9 and 15%. And you would not choose either project if the discount rate was higher than 15%. Another problem with IRR, actually, is that it relies on iteration or guesses. And although it may not be obvious to you when using an Excel function, Excel actually starts with a guess. And where it starts can also lead it to find one of multiple points of equilibrium, or one of multiple IRRs. So in this problem here, you can see a project which has a negative cash flow in year 0, positive cash flows in years 1 through 3, and then negative cash flows again in years 4 and 5. Okay, that's an unusual project. If you were to find the IRR and put in a guess of 15%, Excel would tell you that the IRR is 20.7, and in fact in this third column you can use 20.7, find the discount factors, multiply them by the cash flows and sum them up, and you can see that yes, net present value equals 0. But look at the example on the right. If you put in a guess of 5%, Excel will iterate and generate an IRR of 6.3%. Using that discount rate to find the present value factors and to discount those cash flows, you see that the discounted values are different, but again, the sum of the discounted present values is going to be equal to 0 for an NPV of 0. As you can see, IRR can be very flaky and may give you multiple answers. So which one should you rely on? The answer is net present value. It actually measures dollar values and it uses a realistic reinvestment rate. IRR can be useful, but it doesn't tell you anything about how much money you're making. Projects with higher IRRs may assume that the reinvestment of the cash flows is unrealistically high, which may mean that they're overestimating the profitability. And IRR can be deceptive because it can lead to multiple equilibriums or multiple IRRs. That's it. Thanks for your time today.